Okay, let's talk about the best strategy for balancing chemical equations. So we're assuming that we're given an unbalanced equation that already has the correct subscripts for each atom. So within each molecule or compound we have the correct molecular formula or ionic formula, because we know that we've learned the naming rules already. We've gotten good at this. We are absolutely certain that what we have is correct, minus balancing with respect to coefficients. And that's the next point, is that we can only change coefficients. That's the only thing we can do to balance the equation. Molecules are what they are, ionic compounds are what they are. From the problem, we have to transcribe those correctly, and the only thing we get to do is change the coefficients. This is a effect of Dalton's atomic theory, that we can have multiples of the compounds and the elements, but what they are what they are, so to speak. So we're only changing coefficients given a balance or an unbalanced equation. So the general strategy is we're going to update the tally of each atom after every coefficient, and the strategy that's going to get us there quicker and with the least amount of headache and heartache is to start by eliminating an even-odd imbalance, because we can never multiply an even number to get an odd. Okay, we're always going to get an even if we multiply an even number by any number. But an odd number we can multiply by 2 at the beginning to get rid of that odd number, so that it makes it where we can match up better. Then we're going to balance the atoms that are in the most complicated compounds first. So we're going to deal with those first, because they have the least flexibility, and we're going to save the elements until last because they have the most flexibility. We can multiply those and only affect one thing at a time. Okay, so it just gets us there quicker and with less running around in circles, so to speak. So let's look at what we've got. So we are missing coefficients in each of these locations. Okay, so that's the only place we have the ability to change. And so let's start by looking to see if we have even and odd imbalance. So we're going to write out our elements that are on either side of the equation in the middle. Okay, and on either side of that we are going to tally. And so on the left hand side we've got 1 nitrogen, we've got 3 hydrogens, and we've got 2 oxygens. Right hand side, in the product side, we've got 1 nitrogen and we've got 2 hydrogens and we've got 2 oxygens. So we've got a situation where there is an even-odd imbalance with hydrogen. So I'm going to go ahead and fix that by multiplying by 2. And every time I change a coefficient, I have to retally. So now I've got 2 nitrogens, I've got 6 hydrogens, 2 oxygens. Right hand side is the same. Okay, so I didn't do anything to that. So what do I have to do now? Well, now I've got to get 2 nitrogens. So let's deal with the most complicated first. We just dealt with the most complicated on the left. Let's deal with the most complicated on the right. I guess water and that are pretty close, but let's go ahead and balance nitrogen. Multiply by 2. So now we've got 2 nitrogen, we've got 2 plus 1, 3 oxygen, and we've got 2 hydrogen. So now we've got even odd imbalance again, 2, 3. So let's get rid of that even odd imbalance by multiplying our odd number, 1 oxygen over here. Let's multiply that by 2 to get rid of that odd. I changed something, I've got to retally. Well, nitrogen didn't change. 2 times 2 is 4 for the hydrogen now, and now 2 plus 2 is 4 for oxygen. Okay, so what have I got? I've got now an issue where we need to balance out oxygen still, and we need to balance out hydrogen still. So we've got 6 and 4 with hydrogen. So how do we fix that? Well, we can multiply to the next multiple that 6 and 4 share is 12. So let's get this number to 12. So 4 hydrogens. To get that times 2 hydrogens here to 12, we would have to change this to 6. Okay, you could also look at that as multiplying that 2 by 3. Okay, if you want to do it that way. But we're going to say multiply by 6. Now we've changed something, so we have to retally on the right side. Still 2. Okay, 2 for hydrogen. We've got 12 now, and we've got 2 plus 6 is 8 for oxygen. Look on the left side. Well, let's get this to 12. 2 times 3 is 6, but to get 3, the multiple to get 3 to 12 is 4. So now we have 4 nitrogen, we have 12, and we have for oxygen we still have 2 on the left because we're saving elements till last. Okay, so I didn't pick an easy one to give an example for. Pick the hard one so it'll help you a little bit. Okay, so now where are we in balance? Well, now we have our nitrogen is off, so we can multiply by 4 to balance nitrogen. So now we've got 4, and now oxygen is now 6 plus 4 is 10. We're still at 12 for hydrogen. Okay, left hand side, we're balanced on nitrogen, 12, so we're balanced, and we saved till last our oxygen element, so it has the most flexibility. We can multiply by 5, get 5 times 2 is 10, and now we've got 4, 12, and 10 on both sides, and we're balanced. Okay, so that was a little bit of a complicated one, but we went through the process in order, and it got us to the right answer eventually. Okay, it takes sometimes guess and check can waste a lot of your time. Okay, so we didn't guess and check. We went through the process. We started with the most complicated. We fixed even odd issues first, and then we balanced the most complicated compounds first, or atoms first, and then we saved the oxygen element till last, so it gave us the flexibility to finish it up. Okay, so what if we're given combustion of pentane is the only information given? So we know from our naming rules of alkanes that alkanes have this general formula. Pent prefix means 5, C5H. 5 times 2 is 10 plus 2 is 12, C5H12. We know combustion is oxygen reaction, and we know that forms water, and it forms CO2. And we've got heat release, so it's probably going to be steam. All of these are gases. Okay, so we've got coefficients done. We've got an unbalanced equation. It's ready to balance. So let's create our tally. Carbon, hydrogen, oxygen. 5 on the left, 1 on the right. For hydrogen, we've got 12 on the left, we've got 2 on the right. For oxygen, we've got 2 on the left, and we've got 3 on the right. So even odd issues first. Let's get rid of this odd number of oxygens. Let's mark out our coefficient boxes that we are able to change for balancing. Everything else must remain the same. So there's 1 oxygen here. We can make that an even by multiplying by 2. Every time you change something, you must retally. So 2 plus 2 is now 4 for oxygen. Okay, so look at our most complicated molecules. Okay, and so I guess CO2 would count as well. So let's go ahead and balance carbon. So if we multiply by 5, we would balance carbon here, and so we get 5, 10 plus 2 is 12 oxygens, and we're still at 4 for hydrogen. Okay, so now hydrogen we can balance on the left hand side by multiplying by 3 here, so we've got 2 instead of 2 here, so multiples 3 times 2 is 6, so 6 times 2 is 12. Now we retally. 6 plus 10, 5 times 2 is 10 plus 6, 6 15 for oxygen, and then 5 carbons. Okay, so now we're balanced carbon and hydrogen, and now oxygen left over. The element of oxygen is the simplest, and so we can multiply 8 times 2 is 16. Carbon is still 5 on the left, hydrogen still 12, and we should be balanced now. Yep, 12 for hydrogen, 5 for carbon, 10 plus 6 is 16 for oxygen. Okay, and this must be the lowest whole number, but it is because we have odds and evens that cannot be divided by any common factor. Okay, the 1 does not have to be written.